Hey kids, we have a few things to go over today, and this sheet you have right here, we're looking at right here, I'm going to give you a copy. You should already have it, in fact, so you can look at it as we go through. Okay, watch the video, follow along. This is just a note sheet. It'll be very helpful for your test. I would recommend studying this. Try to commit some of it to memory. Okay, anyway, we've already seen a lot of these. Here what we're going to have is we're going to have, in this column, we're going to have equations, okay, with the symbols. In the middle column, I've got equations where they're written out, okay, with words. And on the far right, in this column, I've got units. Okay, and these units are going to show you the units for just the thing on the left side of the equation, okay? Not on the other side, just on this side. Okay, so speed, acceleration, force, etc. All right, so speed is equal to distance divided by time, right? Speed equals distance divided by time. Now, speed is going to have units of, remember I've told you this little symbol here, an equal sign inside of brackets, it means it has units of. If you want to write that on your paper, point at that thing or something, go for it. Okay, speed has units of meters per second. All right, distance is measured in meters, time is measured in seconds. Our speed is in meters per second. All right, acceleration is equal to final velocity minus initial velocity divided by time. Or you can say that as the change in velocity over change in time, right? So acceleration equals final velocity minus initial velocity. I just wrote this on top of each other because otherwise it wouldn't fit, okay? Divided by the time. And again, you can do the final time minus initial time. So if it's like from 40 seconds minus 10 seconds, right, you can do that. Okay, so acceleration ends up with units of velocity divided by time, which is meters per second squared, right? So you got a speed or velocity divided by more seconds gives you meters per second squared. Okay, that's your unit for acceleration. Okay, next, force equals mass times acceleration. So force equals mass times acceleration, right? Now force is going to end up with units of newtons. And a newton is a complex unit that is actually a kilogram times a meter divided by second squared, right? Kilograms is our unit for mass. Meters per second squared is our unit for acceleration, as we said here. So this is what we end up with, okay? And this is a this is a derived unit, and you can simply call it newtons, okay? And it's good to know that a newton is a kilogram meter per second squared, right? You had a question on your homework yesterday about that. All right, weight equals mass times gravity. So weight equals mass times gravity. All right. Now, weight is just a specific force, right? It's the force of gravity acting on a body. And little g on Earth is 9.8 meters per second squared. That's a good number to remember, okay? Weight will also have units of newtons because it's just a specific force, right? It's the force of gravity. And this equation should only be used on Earth, okay? If we go to a different planet, the value of g is going to change, right? If we go to the moon, the value of little g will change. If we go out in space, the value of little g is going to change, right? But on the Earth's surface, whether you're on Mount Everest or at the bottom of the Dead Sea, g is pretty much constant, okay? It changes a little bit, but not enough for us to worry about. All right. Now, this little g actually comes from this equation here. All right. This equation is the universal gravity equation. Okay, and it's force, F, equals universal gravitational constant times the mass of the first object times the mass of the second object divided by the distance between the two objects squared. Okay, so force is equal to this universal gravitational constant. This is given a symbol big G. And I will not give you any test questions using this equation on your final. Okay, I just want you to understand where weight comes from. Okay, and the force of gravity comes from. All right, so if we were going to use this equation on Earth, right, the mass of the Earth would put for mass of the first object. The distance between the Earth, the center of the Earth, and the surface would be the d, right, that we square. And the mass of the second object would be whatever we're measuring the weight of, right? Like a person or, a weight plate in the gym or whatever. That would be the mass of the second object. Okay, the mass of the first object and the distance are based on physical parameters of the Earth. All right, and again, that'll end up in newtons. Okay, this G is a complex unit. We won't talk about it today. I showed you a video on that last semester, but I'm not going to test you on this. Okay, I just want you to understand where this weight equation comes from, right? Little g is a simplification of big G, the mass of the Earth, and distance from the Earth to the surface. All right, mass of 2 would be equivalent to that m. Okay. All right. Let's go down here. Okay. Here, let's go to momentum. Bet you didn't know that was P, right? P is used for momentum. Why? I don't know. We talked about it last semester. All right. M was already used for mass, so P is used for momentum. Momentum is equal to mass times velocity. Momentum equals mass times velocity. Now, if 2 or 3 or 4 or more objects collide, momentum is conserved. Okay. All right. Momentum equals mass times velocity. Momentum has units of kilograms times meters per second, right? Mass is kilograms, velocity is meters per second. So momentum is actually kilograms meters per second. And there's no, Newton or joule or simplified unit for that, okay? You have to write out kilogram meter per second. Okay. The next one we have is work equals force times distance. Okay, so work is equal to force times distance. If you throw a baseball, the force you apply over the distance you apply the force, not how far the ball travels once it leaves your hand, right? Just the distance over which you apply the force. Okay, if I pick up something and move it vertically, we can actually substitute for this force the weight of the object. Okay, that's how much force I had to exert to lift it, right? It's equal to the weight times the distance that I lifted it. All right. Work has units of joules. Okay, a joule is equal to a Newton times a meter. Or you can say that's equal to a kilogram meter squared per second squared. Okay, force is newtons, distance is meters. A Newton meter is equal to a joule. All right. Now you'll notice that work, kinetic energy, and potential energy all have the same units of joules. Okay, and so does mechanical energy. All right, kinetic energy equals 1/2 times mass times velocity squared. So KE, kinetic energy, equals 1/2, right, fraction, times the mass times the velocity of the object squared. If you're not moving, you have no kinetic energy because your velocity is 0. All right, kinetic energy has units of joules, and we worked this out yesterday in a video, right? Kilograms, meters per second. You square this thing, you get meters squared over second squared times a kilogram. Gives you this guy here, that's a Newton meter, and that's a joule. Okay? All right. Potential energy equals mass times gravity times height. All right? P equals mgh, mass times gravity times height. So kilograms, meters per second squared. Remember, this is an acceleration, and height is a distance in meters. Again, you'll end up with these units, and it's a joule. Okay? And then mechanical energy is just the sum of kinetic and potential energy. All right, so again, it's also joules. Remember, we said that as an object falls or goes on a frictionless path, mechanical energy is conserved. So it could apply to somebody on a swing set, it could apply to a roller coaster, it could apply to an apple falling, towards the earth. Mechanical energy is conserved. All right, great. Okay, so I just added this down here, and I wrote it in pen. I mangled it. But anyway, density is mass divided by volume. We've already done problems with this, and we have notes on this. And they might be more clear than this is, okay? But I thought I'd add it. Density equals mass divided by volume. Density equals mass divided by volume. Volume is typically abbreviated with a capital V. Mass is typically abbreviated with a little m. Density is often given a little d, but since we have that used for distance numerous places on this form, I thought I'd make a capital D for density. Okay? And density has units of a mass unit divided by a volume unit. In the problems we've worked, we've often seen that mass measured in grams and the volume measured in milliliters. Okay, typically, if you really want to be faithful to the SI system of units, you actually have kilograms per cubic meter. Okay, it's kind of an odd unit though because it's a really big number. All right, kilograms per cubic meter. So we often do things in grams per milliliter. All right, water is 1 gram per milliliter. And a lot of like metals, like aluminum, is 2.7 grams per milliliter. It just makes a convenient set of units to use. All right. Okay. Anyway, that's that. Let's see what we're gonna do next. Okay, we're back. Next, I'm gonna look at the units to know sheet. This was in D9 lessons under EOC review. I gave you this a long time ago. All it is a bunch of equivalent statements telling you that 1,000 meters makes a kilometer, 100 centimeters makes a meter, 10 millimeters makes a centimeter, 5,280 feet make a mile, 3 feet make a yard, 12 inches make a foot, 1 inch equals 2.54 centimeters. Number of days in a year, hours in a day, minutes in an hour, seconds in a minute. All right, and then down here we've got mass. All right, 1,000 grams is a kilogram, 16 ounces is a pound, 2.2 pounds is a kilogram, 1 pound is 454 grams. Okay, these things are helpful. I will give you this sheet for your use on the final. Okay, we won't do a whole lot of these problems, but there'll be a couple of them. All right. Okay, so you'll need to know this. I'll give it to you for the final. You can download it, save it on your laptop, look it over, just be familiar with it. Okay, it'll help you out. Thanks a lot.